Can you guys hear me? Not yet? Oh, you can. OK, great. All right, let's get started. So hello, everyone. Welcome. Today, we're going to take a look at how you can build a data lake with AWS Glue Data Catalog. My name is Prajakta Damle, and I'm the Senior Product Manager for AWS Glue. So before we get started, how many of you here are building a data lake or have a data lake already in production or aspire to build a data lake? Cool. Almost all of you. That's great. You're in the right session. And how many of you are using Glue or have heard of Glue? That's a good number. So for those of you who are already using Glue, thank you for using the service. If you have any feedback, find me after the session or email me. And for those of you who haven't tried us out yet, I hope I give you enough details in this session for you to at least give us a try. So with that, let's get started. So today, we'll take a look at what is the data challenge that we face, do a quick refresher on what a data lake is, and then spend the rest of the time really looking at what Glue Data Catalog is all about. We'll take a look at what it offers, how it catalogs your data, and once your data is cataloged, how can you really make use of that? What can you do with it? How can you derive insights? I'll also leave some time after the session for you to ask me questions. I'll also be available here for one-on-one questions. So let's get started. So what does your data look like? You have your clickstream data, your mobile app data. You have spreadsheets, financial billing data, financial documents. You also have a ton of logs. And you have social media data from a variety of sources. You have your application databases. You have data warehouses on AWS. You have data warehouses on-premise. You have ERP data. And then today, more than ever before, you have a lot of streaming data. You have sensor data. You have devices sending you IoT data. And many of your social media sources or clickstream data is also being probably streamed in. So how do you deal with these multiple formats, sources? And this picture probably keeps changing every single day. So how do you make sure that your data is not siloed? It's available for various different use cases in your organization. So you might ask, this is not a new problem. We have been dealing with massive data volumes and growth in data volumes for many decades now. Enterprise data warehouse was the center of our universe for many, many years. So why is this a new problem today? Today, more than ever before, we're really seeing a shift in the type of data that we are acquiring. We're acquiring a lot of unstructured and semi-structured data. So the balance is really tilted towards data that needs to be quickly understood, quickly pivoted, relationalized for you to really run any analytics on it. What this also leads to is a problem of dark data. So what is dark data? Dark data is data that you acquire and that just sits around without really being available for any analytics. As you can see here, over the last few decades, the amount of data has exponentially grown, but the data that is available or made available for analytics hasn't really changed much. To add to that problem, you have multiple consumers today. You have your analysts. You have your business users who want to visualize your data. You have your data scientists who want to run predictive analysis on your data. And then you have various different applications who are consuming various forms of this data, either in raw form or in aggregate form. And then these consumers have new requirements. They want your data to be their data to be available as soon as possible. They want it to be flexible to support a variety of different use cases, from batch analytics to real-time analytics to something like running their machine learning algorithms on it. And they want to do this at massive scale. So this often leads to data duplication. You have multiple different groups creating copies of your data, keeping it in various different repositories without you really having a unified view of what data you own. So this brings us to a data lake. So what is a data lake, and how does it help you deal with these two challenges? So data lake is an architectural approach. It helps you store and ingest any kind of data. It not only helps you store data, but it also helps you organize the data, curate it, and understand the data so that it's easy for you to quickly find that data. And then it gives you ways to make this data available to a diverse group of people in your organization with the right set of access policies. Data lake is also a place where people can run multiple different types of analytics. So a data lake needs to be future-proof. It needs to support things like natural language processing, as well as querying and dashboarding and visualization of your data. So these are some of the key benefits of a data lake. A data lake needs to allow you to quickly ingest and store any kind of data. It needs to provide you a single source of truth, so you can dive deep and find the relevant data sets quickly when you want them. And then it needs to provide you with a set of unified tools to query and analyze this data. So let's take a look at what a typical data lake looks like and what are the layers of that data lake. You have your storage or ingest layer. So if you're building your data lake on Amazon S3, you have a variety of AWS services that will allow you to ingest data from bulk transfer using a snowball to doing continuous replication of your data using database migration service to streaming your data in with Amazon Kinesis. You then have a variety of security services that will allow you to protect and secure your data. So you can use Identity and Access Management Service to set the appropriate policies and rules on your data. You can use the Key Management Service to encrypt your data. And once your data is protected and encrypted, you now have a host of services to analyze your data. From Athena, that allows you to query directly against data on S3, to Amazon Redshift, where you can build your data warehouse on AWS and load some of that data into your data warehouse, to Amazon QuickSight that can allow you to visualize your data, and then EMR that allows you to do further processing of your data. This is just a sample of the services that AWS offers, and if you have been in the keynotes, this picture has probably already changed. And then we have a host of AI services that allow you to further analyze, process, and build your sort of machine learning models on top of your data. You can do speech recognition, text-to-speech, image analysis, using a variety of AI services that AWS offers. But there's still a missing piece. And what is that missing piece? There's still no unified view of all the data that you own that is available to all the services that are part of your data lake. So this unified view helps you find and quickly understand the data that you own, no matter where it is stored. It should be integrated with your analytics services, so the same data is available and accessible from various different places. And then there should be a way to automatically build and maintain this metadata as your data evolves. So now let's take a look at what AWS Glue is all about. AWS Glue provides you three things. It helps you discover and understand your data so that you can quickly search and query this data. It then helps you develop the code necessary to clean this data, enrich this data, combine it from various different sources, and process this data, as well as move this data between various different repositories. The code that Glue provides is customizable, and you can also bring in your own code. And then once your code is ready, Glue provides a serverless execution environment for you to run this code and put the necessary orchestration features in place to schedule this and trigger this on dependent conditions. These are some of our customers. We have customers who are migrating their enterprise data warehouses to Amazon Redshift using Glue. We have others who are getting raw data, converting it to a columnar format like Parquet, repartitioning it, and storing it on S3 so that it can be easily queried with Athena as well as Amazon Redshift Spectrum. And then we have yet others who are building their machine learning algorithms using Glue. So Glue has three main components. There's a data catalog, which is Hive Metastore compatible, integrated with various different AWS services. And we are actually going to take a very detailed look at this particular component in the rest of this session. But Glue has many other components, two other components that provide job authoring, as well as job execution for your data processing and ETL code. So what is a data catalog? So a data catalog is a list of your metadata. It provides you a unified list of your metadata no matter where your data is stored. Your data could be in Amazon S3. It could be in various different relational databases. It could be in your data warehouse on Amazon Redshift. It automatically classifies this data and categorizes it so that it's easily searchable. It tracks the data evolution by automatically versioning your schema definitions. And then it integrates with various different AWS services so that you can quickly query your data, and then you can do further analytics on Amazon EMR. So this is what a data lake looks like with Glue. You have your crawlers that can automatically scan and catalog your data on Amazon S3. You have your Glue ETL Jobs that can process data and put it back on Amazon S3. And then the Glue Data Catalog provides you the unified view that is also available to a variety of analytics services on AWS. But there are many different ways of thinking about a data lake. One way is to put all your data on S3, but you might have data in various different AWS services. And you still might want a unified logical view of your data and want to build a logical data lake. Glue supports that use case as well. Crawlers can go and crawl data across various different data sources, and then you can visualize that data in using something like a Zeppelin notebook that connects to the Glue Data Catalog. So here you can see that we can spin up a Zeppelin notebook, connect it to Glue's serverless environment, and read and write data in various different data sources by leveraging the metadata that is in the Glue Data Catalog. So how do you set up the Glue Data Catalog? You can create your tables manually, and this works great if you want to quickly go and test out a use case where you know the schema and you want to quickly add that using our console. You can run Hive DDL statements. So here you can see an example where you're doing a create table against a set of ELB logs. And you can also use the Glue APIs to create tables directly in the data catalog. This works great if you just have a handful of tables to create and maintain. But when you are dealing with hundreds of thousands of tables, this method is not very scalable, and it's also very error-prone. As your data changes, you now need to go and manually make edits. Otherwise, your downstream processes would break. So we provide an easier way for you to catalog your data and then keep it up to date as your data evolves. You tell us where your data is, and you tell us how often you'd like to check for updates. And then Glue Data Catalog goes and scans your data repositories, builds your data catalog, and then provides you this list that is searchable and queryable. So here you can see you have tables that are mapped to data on S3. You have tables that are coming from your Redshift data warehouse, as well as tables that are coming from your Postgres database. So how does Glue automatically catalog your data? Glue uses crawlers that can go and sample various different objects that you have stored in S3, as well as scan the databases that you give us access to, and then extract relevant details like the schema information, data statistics, and add them as table definitions to the Glue Data Catalog. Crawlers also apply a set of classifiers to classify your data based on well-known formats as well as well-known patterns. And it provides you the flexibility to write your own classifiers if you have data that is not natively supported by the Glue crawlers. They discover schema as well as discover changes in schema. So over time, they can version your schema definitions. And for data on S3, crawlers can also automatically detect and register partitions. So you can schedule a crawler. You can also run it ad hoc on demand. And they run on Glue's serverless environment. So there are no resources for you to provision or manage. And you only pay for the crawlers when they actually run. So let's take an example. This is a snapshot of a GitHub archive data that archives all the events that happen, such as new commits, forks, comments on GitHub. It's aggregated every hour, and it's available for you to download through any HTTP client. It has 20 different types of events, and then it has many nested types, event types, with unique payload for each event type. So when we crawl that data set, this is what the table looks like in the Glue data catalog. As you can see, you have the location of your data. You have certain properties, such as your survey information automatically populated. You also have certain data statistics, like your average record size, number of records in the data set, populated in the data catalog. And then finally, you have the table schema, including nested types. You can see an example of the payload nested schema expanded here, which shows you an arbitrarily nested JSON schema. So this has been automatically extracted and added to the data catalog by the Glue crawlers. So how do crawlers automatically detect your schema, extract it, identify what classifiers to apply, and then classify your data? So what crawlers do is they sample your data, and then based on the sample, they apply a set of classifiers to that sample data set. And based on what certainty number is returned, they determine if there was a match or not. If there was a match, then the crawlers will use that classifier to extract the schema, as well as apply that classification to your table. Glue provides a set of built-in classifiers, but you can write your own, and we'll take a look at how you can do that in just a few minutes. So this is how Glue would classify your data on S3. It would enumerate the objects on S3, and then identify the schema at each file or object. It would apply a set of classifiers to that object, and then it would merge that schema for objects that are similar or have the same classification. And then finally, you would get the schema at each partition level, and then at each table level that would then get added to the Glue data catalog. So the way Glue determines if there was a match or not against a particular classifier is based on the similarity index that it generates. So it assigns a point for every match of name, as well as a point for every match of data type. So here in this example, you can see that it assigns a point for the root because it matches a name. It also assigns a point for name as well as ID, and also address. But for data types, the address is not matching in data types, so it will only assign a point for the data types of the other 3 nodes. So you would get a similarity index of about 87%. And for any similarity index above 70%, Glue would assume that there is a match, and then continue to combine schema and build your table definition. So these are the built-in classifiers that Glue supports. Glue can crawl a number of databases, Amazon Redshift, and then a number of formats on S3. You have your columnar formats like Parquet and ORC. You have your semi-structured formats like JSON and BSON, as well as a number of logs and compression types that Glue supports. But if this list is not enough, you can create your own classifiers using Grok expressions. And Grok is essentially just a regular expression that you can specify. So let's take an example of a Grok expression. Here I have crawler logs and a Grok expression that identifies the schema for crawler logs. So when you run your crawlers, we generate logs that you can download and put in a S3 bucket. This is an example of a regular expression that identifies the schema of crawler logs. And this is not a new or custom pattern that Glue has developed. This is something that you probably already use to identify different log patterns. Grok expressions help you identify 200+ Apache log formats. So you can define a Grok expression for a specific set of logs that you generate and that you want to identify with a specific classification. So once you have your custom classifier written, you add it or associate it with the crawler that you want it to be applied with. And then the next time the crawler runs, it would apply it to the data that you have stored in the repository that the crawler is scanning, and you'd get a table in your data catalog with the custom classification that you have specified. Glue automatically detects partitions in addition to the table's schema based on the data that it scans. So here, going back to the GitHub archives example, you can see that in addition to the table schema, Glue has also detected partition keys and registered those. It has registered the available data as available partitions in the Glue data catalog. And once this is registered, you could just readily go to Amazon Athena or go to EMR and start querying this data. So if you have new data coming in every hour, every day, and you have a crawler running on a schedule, you can always have the latest data available for all the querying needs that you have. So how does Glue detect partitions? It does a similar analysis as it does to detect whether there is a schema match. So it starts generating schema and starts merging that schema based on similarity at the file level, and then keeps walking the S3 bucket hierarchy up to determine whether all those files in a given bucket map to a single partition, map to multiple different partitions that are part of a single table, or map to different tables. Glue also, with crawlers, determines whether there was a schema change. So if a new drop of your data has additional fields, has fields that have changed, Glue can detect that, and it can find the table in the catalog and automatically version your schema. So you might say that, this is great. Crawlers can crawl my data, but I already have an existing external Hive metastore, and I already have all my metadata there. So how do I get that data into the Glue data catalog? Well, we have an import script as well as an export script. So if you have an external Hive metastore that is backed by a MySQL database, you can run our import script as a Glue ETL job and get your metadata from that Hive metastore into the Glue data catalog. You can also export that data out to an external Hive metastore if you ever need to take that data and put it in an external Hive metastore for any use case that would require a dedicated external metastore. And you can find that script on our GitHub repository. If you go to Glue developer resources page on our website, you'll find the link there as well. So your data is cataloged. That's great. What next? How do you use this data? So you can search. So you can do a text-based search. You can also filter on key attributes from the Glue console to find relevant data sets. So as you can see here, I've searched on the term log, and then I've gotten data sets that are mapping to CloudTrail data, ELB data, as well as the custom classification example that I just showed, which maps to crawler logs. And then I can pick the relevant data set and then immediately start querying it from the Glue console itself using Amazon Athena. I can write pretty detailed queries. As you can see here, I have a query written against the CloudTrail data and get results right through my console. So with the Glue data catalog, you can analyze data and have access to the same view of your data through multiple different engines. And then you can visualize that data using Amazon QuickSight. So quick refresher on what are these different engines. Amazon Athena provides interactive querying, SQL-based interactive querying directly against data in S3. It is completely serverless, so there are no resources for you to manage. And you only pay for the data that is scanned when your queries run. Amazon EMR provides you Hadoop on AWS for big data processing. It provides support for 19 different open source formats. And you can use the Glue data catalog as your external Hive metastore for big data applications running on Amazon EMR. And then if you have your data warehouse in Redshift, and you also have data on Amazon S3, you can use Amazon Redshift Spectrum to run queries against your data on S3, do a join between the data in Amazon Redshift and S3, and run hexabyte scale queries just in a few minutes. Glue also helps you do serverless data exploration. If you have your data scientists who want to use Spark notebooks and interactively run Spark SQL, interactively build your ETL scripts, they can create a Glue development endpoint and attach a Spark notebook to it to interactively work with their data. The Zeppelin notebooks can access the metadata in the Glue data catalog through the Glue development endpoints. And then you can have access to a variety of data sources that Glue supports. You can also use Glue ETL Jobs that can read metadata from the Glue data catalog to move data across multiple different sources. So if you have raw data on S3 and you want to load all of it or some of it into your data warehouse in Amazon Redshift, you can create a Glue ETL job, and Glue will also provide you with an auto-generated script. That's a good starting point for a lot of ETL jobs. And then you can run that on the serverless Apache Spark environment that Glue provides to move that data from one data repository to another. So let's take a look at what a data lake offers, as well as what a data warehouse offers, and when do you use which. So a data lake helps you store a variety of data formats. These could be structured, semi-structured, or unstructured. It provides you the ability to apply schema on read. And it supports a variety of different use cases, from data science use cases to BI use cases, to just use cases where you want to do ad hoc analysis. It helps you store granular data as well as process data. And it helps you scale your storage without really scaling your compute. So it provides you the separation of compute and storage. Data warehouse, on the other hand, provides you an easy way to store structured data. It provides you simple tools to run SQL-based analytics. And it is great to store frequently accessed data that needs to be aggregated or summarized and made available to your dashboards. So with Glue, you can actually interoperate your data lake and your data warehouse. You can bring in your data into Amazon S3. You can load your recent or most frequently accessed data to Amazon Redshift. You can compute your aggregates inside of your data warehouse. And then you can unload that data and put it back on Amazon S3 for historic archiving and also to make it available for ad hoc analysis, as well as for any data science analysis that you have or that you want to do within your organization. So with Glue, you don't necessarily have to choose one or the other. you can easily interoperate both your data warehouse and your data lake on AWS. So I have a few key announcements to make. We will be releasing support for Scala very soon. So in addition to writing your Glue jobs in PySpark, you would now be able to write your Glue jobs in Scala. And then Glue will be available in 2 additional regions very soon, in EU West 1, as well as in AP Northeast 1, which is our Tokyo region. So that's all I have. And I will be available for questions. We also have some Glue stickers back there, so feel free to help yourself or feel free to take those as you walk out. So thank you, everyone.